great flexibility and resilience. For example, in this book, Dr. Sean Inderbitzen proposes neural exercises that challenge autonomic regulation via withdrawing and re-engaging the vagal brake, which would promote a general enhanced state of regulation observable in behavior, emotion, and physiology. When I started my academic career in 1970, autism was considered a relatively rare disorder that was assumed to be characterized by two features: 1, permanence of the disorder, and 2, a genetic basis. These plausible assumptions biased and limited the research questions and the explanations that both researchers and clinicians could use to describe their observations in both the laboratory and the clinic. The scientific community, as well as my first publication mentioning autism, readily embraced these assumptions, which had consequences on research funding. Funding priorities within the National Institute of Mental Health reflected this transition, prioritizing projects involving molecular genetics in a concerted effort to identify a genetic substrate. This diverted funds from other, more flexible, optimistic perspectives that might be conceptualized as neural exercises to optimize the life experiences of those with an autism diagnosis. This decision was costly to the science of understanding autism and to the autism community. Under these assumptions, when clinicians and researchers observed that an individual, via maturation or intervention, no longer reached criteria for autism, they were confronted with the consensus view that the initial diagnosis was faulty. This perspective had great impact on intervention models, interpretations of research findings, and even the astute observations of clinicians who were effective in optimizing the function of their autistic clients. Explaining to colleagues or parents that an individual no longer reached diagnostic criteria following an intervention or with maturation challenged clinical researchers in how to disseminate this information. If they proposed that the intervention functionally normalized the previously diagnosed autistic individual, then they could be accused of claiming to cure autism. Such a label would be sufficient to exclude a researcher from opportunities to publish in peer-reviewed journals and from obtaining funding from the National Institutes of Health, and could even impede career advancement, e.g. university tenure. Yet, within the community of researchers and clinicians, there were frequent discussions of possible explanations for shifts in severity of autistic symptoms. The first potential source of variation in clinical sequelae was diagnosis. Thus, it was assumed that if the communities studying and treating autism used a common diagnostic tool, there would be more consistency in diagnosis. This should lead both to fewer false positives, those who reverse symptoms through maturation and intervention, and to systematic evaluations of interventions reputed to normalize autistic behaviors. In the 1990s, transformative research headed by Dr. Catherine Lord established a convergence between assessment tools and consensus of expert clinicians. These tools, the Autism Diagnostic Observation Schedule, ADOS and ADOS-2, and the Autism Diagnostic Interview, ADI and ADIR, are considered the gold standard for diagnosing autism and have led to the more inclusive diagnostic category Autism Spectrum Disorder, ASD. The availability of these assessments framed peer-reviewed research on autism and became an important criterion to publish and receive funding. However, and this is crucial, this strategy assumed that consensus judgment was sufficient to operationalize diagnosis. This is a powerful assumption, that the behaviors observed by clinicians were sufficient to identify a disorder assumed to be genetic, or at least to have a permanent neurobiological substrate. This assumption, in practice, depends on accepting that biology and physiology parallel psychology, which often is not the case. This model of parallelism, which assumes continuity across